Now the next is association of solute. Okay, and association of solute occurs mostly in non-polar solvents. Okay, for example, benzene is your non-polar solvent like this. Now what is the meaning of association? Association means 2, 3 or more molecules exist in combination. Now when 2 molecules join together, it is known as dimer. When 3, it is known as trimer, and so on. Now one example I am taking here to explain this. For example, acetic acid. When acetic acid is dissolved in benzene, benzene is a non-polar solvent, it dimerizes. So 2 molecules of acetic acid combine to form a dimer. Now what will happen? Number of particles will decrease. Suppose you have taken 100 particles of acetic acid, 100 molecules you have taken. So resultant will be 50 only. So number of particles will decrease. If number of particles decrease, the magnitude of colligative property will also decrease. And the observed molar mass will be more, because colligative property is inversely related to the value of molar mass. Clear? Now, what is the normal or theoretical molar mass for acetic acid? Is 60. But from the colligative property, if I calculate the molar mass, that is my abnormal or experimental molar mass, it will be 120. Now it is just double. Why it is just double? Because the number of particles are exactly halved here. And this is known as abnormal molar mass. Okay, so when dissociation is there, the molar mass is less than the actual value, and when association is there, the molar mass is more than the actual value. Now how to solve this problem? Is this clear? Because mostly the solute particles may associate or dissociate in the solution. So Vent Hoff factor we will use here. And what is Vent Hoff factor? Vent Hoff introduced a factor I to express the degree of dissociation or association of solute in the solution. And what is this Vent Hoff factor? It is nothing but it is the ratio of normal molar mass to abnormal molar mass. Okay, what is normal molar mass? It is theoretical molar mass. Theoretical means by using the knowledge of atomic masses, we'll calculate it. And what is abnormal molar mass? This is experimental molar mass. Experimental means by using the colligative property formula, we are calculating this. Is this clear? So the ratio will give you the value of I. Now molar mass is inversely related to colligative property. So one more formula we can use: experimental value of colligative property divided by normal value. Normal means theoretical value, what we are expecting. And what is that? So experimental means actual value, what we are observing in the practical, and normal means theoretical, what we are expecting. Clear? Value of colligative property. So this ratio will give you the value of I. If I is less than 1, now what is the meaning of less than 1? Less than 1 means abnormal molar mass is more and normal molar mass is less. So if abnormal is more, it is the case of association. If I is greater than 1, it means normal is more and abnormal is less. It is the case of dissociation. And if I is 1, it means normal and abnormal both are equal. So no association or dissociation is there. So this is the concept of Vent Hoff factor. Now what we'll do here next, we'll modify all the colligative properties. Okay, and the modified equations for all the colligative properties are, what we'll do, the formula is same, but in this formula we'll use this factor I. So P naught A, my first colligative property, relative lowering of vapor pressure, P naught A minus PS upon P naught A is equal to I into XP. Delta TB is equal to I into KB into M. Delta TF is equal to I into KF into M, and pi is equal to IC RT. So these are the modified colligative properties now. And when we'll use the formula I, factor I in the formula, when we see that the solute either associates or dissociates. Clear? Now related to this part is calculation of degree of dissociation and calculation of degree of association, because definitely we'll get a numerical on this part, and the first part of the question will be calculate Vent Hoff factor, and the next part will be how much percentage it is dissociated. Degree of dissociation means percentage dissociation or percentage association. It is denoted by alpha. What is alpha? Alpha is number of moles dissociated divided by total moles taken. This is the meaning of alpha. And how to find out alpha if dissociation is there? The formula, directly I am writing the formula here, no derivation is required here. So I minus 1 upon n minus 1. What is I? Vent Hoff factor that we can calculate, and n is the number of particles after dissociation. Okay, now this will be clear to you when we'll be using this formula in the numerical. And what is degree of association? Degree of association is also denoted by alpha, and alpha is I minus 1 upon n minus 1. Okay, now here n is the number of particles after dissociation, and here this n is the number of moles or particles which associate. So you have to remember these two formula.